Welcome to this presentation on packet analysis with Wireshark. In this video, we will cover how to capture and analyze network traffic using Wireshark, a powerful and free tool. Let's get started. Wireshark is a network protocol analyzer that captures packets in real time and displays them in a human-readable format. It is an open-source and cross-platform tool, meaning it is free to use and available on various operating systems like Windows, Mac, and Linux. Wireshark is considered the industry standard for network troubleshooting and analysis due to its extensive features and capabilities. It includes components like Capture Engine, Protocol Analyzer, and Display Filters. Let's take a look at the main elements of the Wireshark interface. At the top, you'll find the menu bar, which contains options for file operations, capture settings, and various analysis tools. Below the menu bar is the toolbar, offering quick access to common functions such as starting or stopping a capture and applying filters. The largest section is the packet list pane. This area shows a summary of each captured packet, including its number, timestamp, source and destination addresses, protocol, length, and a brief info description. When you select a packet from the list, the Packet Details pane displays the protocol details of the selected packet, broken down into a hierarchical structure. Finally, the Packet Bytes pane shows the raw hexadecimal data of the selected packet, allowing for in-depth analysis of the packet's contents. To start capturing network traffic, first, select the network interface you want to monitor. This could be your Ethernet connection, Wi-Fi, or any other network adapter. Next, configure any capture options, such as setting capture filters to limit the traffic you capture, adjusting the buffer size, and enabling name resolution. Once you have configured your options, click the shark fin icon in the toolbar, or press Ctrl+C to begin the capture. Wireshark will now start capturing packets in real time. To stop the capture, click the red square icon in the toolbar, or press Ctrl+A again. Wireshark will then stop capturing traffic and display the captured packets. Capture filters are used to limit the packets captured by Wireshark, which helps to reduce the size of the capture file and focus your analysis on specific traffic. Here are some common capture filters. Host followed by an IP address captures traffic to and from a specific IP address. Port followed by a port number captures traffic on a specific port, such as port 80 for Hypertext Transfer Protocol traffic, or port 443 for Hypertext Transfer Protocol secure traffic. TCP captures only transmission control protocol packets, while UDP port 53 captures domain name system queries. ICMP captures Internet Control Message Protocol traffic, which includes ping and traceroute packets. Finally, ARP excludes address resolution protocol packets from the capture. Capture filters use Berkeley Packet Filter or BPF syntax, which follows the format protocol direction type value. You can combine filters using logical operators such as AND, OR, and NOT to create more complex filters. Remember that capture filters are applied before packets are captured and cannot be changed during the capture. For post-capture filtering, you should use display filters instead. Display filters are used to filter packets after they have been captured, allowing you to perform detailed analysis on specific traffic. Here are some common display filters. IP address == an IP address filters traffic to or from a specific IP address. TCP port == 80 filters Hypertext Transfer Protocol traffic. Hypertext Transfer Protocol filters all Hypertext Transfer Protocol traffic, while Domain Name System filters domain name system queries and responses. TCP flags synchronize == 1 filters transmission control protocol synchronize packets, which are used to initiate a connection. Hypertext Transfer Protocol request method == get filters Hypertext Transfer Protocol get requests, and frame contains password filters packets containing the text password. To use display filters, enter the filter expression in the filter bar at the top of the Wireshark window. Wireshark will highlight valid filters in green, invalid filters in red, and deprecated syntax in yellow. Display filters offer more flexibility than capture filters, as they can be changed at any time. In contrast, capture filters are applied before the capture, use Berkeley packet filter syntax, and cannot be changed during the capture. Analyzing Transmission Control Protocol, or TCP, connections is crucial for understanding network communication. TCP uses a three-way handshake to establish a connection. First, the client sends a synchronized packet to the server. Second, the server responds with a synchronized acknowledgement packet. Finally, the client sends an acknowledgement packet to the server, establishing the connection. To analyze TCP connections in Wireshark, you can follow a TCP stream by right-clicking a packet and selecting Follow TCP Stream to see the entire conversation. You can also identify connection states using TCP flags such as synchronize, acknowledgement, finish, and reset. For example, TCP flag synchronize = 1. Sequence numbers can be used to track data flow and detect missing segments using the filter TCP analysis loss segment. Retransmissions can indicate network problems causing packet loss and can be identified using the filter TCP analysis retransmission. Finally, you can visualize TCP performance using statistics, TCP stream graphs, and time sequence graphs. Analyzing Hypertext Transfer Protocol, or HTTP, is essential for understanding web traffic. An HTTP request typically includes a GET method, the path of the requested resource, the HTTP version, the host, user agent, accepted content types, connection type, and any cookies. An HTTP response includes the HTTP version, a status code such as 200 OK, the server information, date, content type, content length, and the actual content such as hypertext markup language. To analyze HTTP traffic in Wireshark, use the display filter HTTP to isolate HTTP requests and responses. You can examine request methods by filtering for specific methods such as HTTP request method == post. You can also analyze response codes to find errors or specific responses. For example, HTTP response code == 404. Wireshark also allows you to extract files from HTTP sessions by going to File, Export Objects, HTTP, and you can view complete HTTP conversations in a readable format by following the HTTP stream. Wireshark can be a valuable tool for detecting network threats and vulnerabilities. Some common network threats include port scanning, which involves rapid connection attempts to multiple ports, identified by the filter TCP flag synchronize == 1 and TCP flags acknowledge == 0. Address Resolution Protocol, or ARP. Poisoning involves suspicious ARP replies that could indicate man-in-the-middle attacks, identified by the filter ARP duplicate address detected. Domain Name System, or DNS. Tunneling involves unusual DNS queries with excessive data or frequency, identified by the filter DNS query name length greater than 50. You can also use Wireshark to identify malware communication by looking for unusual traffic patterns or connections to known malicious IP addresses. To detect these threats, you can perform baseline traffic analysis to establish normal network patterns and identify anomalies. You can analyze protocol distribution via statistics, protocol hierarchy. You can identify unusual connections via statistics, conversations, and you can use Wireshark's built-in expert system to flag suspicious packets with the filter expert severity == warning or expert severity == error. Finally, you can look for unusual timing patterns that may indicate automated attacks. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.